Hey everyone, this is Will from Productions², and we're going to go ahead and continue and probably complete the recording for our 9th developer's log, I believe is what this is now. So let's go ahead and talk about some of the changes I've been doing today. I made some changes that are kind of added on to the changes we made the last couple days. Well, let's discuss first the paradox and enormousness of creating a fully moddable program. So, when you think of a program that's moddable, that can support mods, you probably think of a game like Half-Life or, Half-Life series, or a game like, I guess, Mountain Blade, or what else would be a good example of it? Sins of a Solar Empire. Those are, I guess, 3 off the top of my head that I can think that support modding, that have, or Skyrim too. Skyrim also has modding, that have large modding communities. Now, the one thing about that game is that most of the modding that can be done is really, what you would call maybe on the surface. There is a lot of inroads into the code as far as that goes because of the scripting system that those games use or have, or the access that's allowed. But to a point, there can be at a certain point there can't be any modding going on. For example, there may be some code that is dependent on hard code, and so you can't modify that. Like, for instance, you probably can't add new resources, like new cost resources to Mountain Blade, or maybe you can't add new game modes to Sword of the Stars too, but Sins of a Solar Empire. Or maybe for Sins of a Solar Empire you can't add an example that will be true for, I guess again, some sort again for Sins of the Solar Empire, the resources. But I was just sitting here thinking while I was working on the database code, I believe, or is it data system? I think it was database somewhere. Oh, here it was, yeah, database, data system H. I was just thinking, after I did that one for resource, I was thinking, this game is going to be 100% mod friendly, then resources have to be moddable as well. And so then that got me thinking, and that's what you were seeing over here was this. Just a note to myself to make sure that this got done. And essentially what I have devised is that under normal circumstances, resources would not be able to be mod friendly, let's put it that way. You weren't blah 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 blah. I'm having a hard time talking right now. You wouldn't be able to add a new resource in and you have the game used as like a cost resource. Like you couldn't add in super uber element X and say, okay, well the player has to have 5 units of super uber element X in order to buy a super uber space cannon or something similar. Because the resources and the costs code, the code that gets the cost for items is all hard coded. Well, I was thinking about that for 6 or 7 minutes, and I think I may have devised a way, as you can see what's written down here on the bottom, a way to do this, and that is that we will take the costs, and this is for specifically only There's another rub now that I've thought of this. That is the importation of said data. If you add it into the so maybe what I'll have to do is we'll just have to take all the resources together and do them all the same way like this for everything. So you can import all the resources and all the values in one go. Because while I was just sitting here talking, I thought of a way that would still fail. And that is that the data system would have to be hard-coded. So our database is hard-coded. So in order to add new resources to items in the database, you would still have to be able to get to the hard code to add the resource field into the data retrieval for that particular item, whatever it is you're trying to get. So we'll probably end up doing this with everything, so that would make it work properly. But essentially what happens is we just take all the resource names, put them in one string, and delimit them by, as you see there. I think that's not actually how you spell delimit, though. Actually, yeah, it is. I was missing a D. Delimited. And use the hyphen as a delimiter, so that we can split that string based on that delimiter, and then get the names, and do the same with the values, either what the player has if it's a save file, or what the item costs if it's in the database. And the reason that would work is because I'm going to be taking resources and just exploding it out into a new class called resource, or resources, or whatever. And each resource will have its own element made from that class, and so we'll have another vector. And then why that works is because now we can take the split value and name strings, which will now be vectors, and we just load those pairings into each element to get the cost or to get what the player has. And then we take that and use that with a for loop, counting the number of elements, and then we get the resource costs that way from the database. And so that would be able to sync up with the save file, and if the mod maker had added in the extra resource to the game. There's still one way that could fail, though. I'm trying to think of ways that could fail. And another way is that how would the game know how to make those resources now? Since we're taking them and putting them into a vector, that means they have to be made from scratch. Even though these are made from scratch too, but the game wouldn't be making them on its own. And if there were custom resources, the game wouldn't know, there are resources at all. So maybe we'll also have to create a INI file, or entry in the INI file that will have just names of resources that it will look for and then load those in automatically at the start of a game. So I'm going to write that down here too. Make sure resource names are loaded from INI file. I'll say INI or CFG. Alright, so what I've been doing is I've been expanding on the whole asteroids idea that we had started up last time, and I'm actually right in the middle of adding in things so that we can get data from them. That's what you saw me doing over here in database, or data system H, was this, and that's where we're going to start from now. From right now. So we just got done with the resources. We need to do units, R produced, R cost, and RP lost. This used to be RU lost. I changed it to RP loss. So it stands for resource production loss instead of resource units lost. It just sounds better this way and a little more less corny. You know, are you lost? Get Boost Mobile GPS. No. I just got done watching some Aqua Teen Hunger Force and was watching the Boost Mobile episode. I think it's hilarious. But, yeah. Another thing that I'm doing now, that I'm going to be doing in 0.6, is essentially just completely rewriting the whole database class yet again. Except this time we're going to be adding some efficiency into it, and that is, I'm going to go through, and since we're going to have tables that have multiple multiple types for in them, but have the fields for all of them, we're going to go through and only put in the fields that we actually need. So, for example, and I actually did this. No, I guess this one's right, but there'll be times when you need to do it differently. But for example, with resources and ore, what I essentially did was we just created two different data querying functions. And for resource, I only got the first three or four fields from resource data. And for data, or for ore, I got all of them, because resources will only use the first four, while ore uses all the rest of them. And then whenever we add anything else and that uses into the resource data that uses something else, then we only get those specific fields. So let's say that we had an item that used the first four, used the resource name field, and then other couple fields. So we'd only have the first four, then case 7, which is field 8, and then let's say I had 3 other fields, so then we'd have case 12 through 14. No, 14. 12 through 14, getting that data. But you wouldn't have 8 through 11 or 5 and 6 in that query function. And that's essentially representative of what I'm going to be doing with everything else. Because what's going to happen is that equipment's going to actually get folded up into one huge database. Essentially, it's going to be having everything that's cannot be categorized as equipment. So ships and weapons are going to get folded into it as well. And we'll be doing that during 06. And what will have to happen then is that we'll have all these fields for it, and we'll have to go through and only take out the data that we need and leave everything else, so that we're not loading data, spending CPU time loading data that we don't even bloody need. So it'll be more efficient that way, I think, and also make the table a little more clean, I think, overall, and not have so many tables that have to be queried. It'll still be the same number of queries being done, but not to as many tables. I don't really know if that matters or not, but it just works for the consistency of the data as far as that's concerned. Something can be categorized as equipment, it should be in the equipment data table. But let's go ahead and continue with this. Let's see, let's go down with resource. So we need to do R units, R produced, R cost, and RP loss. So R units is a float. Actually, it's O R units, or refine unit. Let's see. Produced is an int, and cost is an int. Int get O produced, OR produced, and Damn it. Come on, semicolon. Get OR cost. And then float for loss. Alright. Now we need to take these functions and add code to them in Data System H, or CPP. Let's put those separately in. Alright, so now we need to pull these back. Alright, let's go ahead and grab this. I'll just change all these en masse. Oops, missed the space on that one. Alright, and take off the semicolons, so we're not redefining something that's been defined already. And start adding the code here. So, get res name resource dot add 0 dot r name. That should be return. Resources, and then do the same for this. Let's make this much faster. I don't know why I didn't think of this earlier. So speed things up at least 3 times. I have to do all the typing for the first half of that. Or SG 2. Oh, stage. I'm also going to the changes I made to the or calculations and stuff, such things like that. So I had to make some changes there as well. OB size. I changed the field name of size to base size instead. That just makes more sense to say base size instead of size, because it isn't actually the size of what an asteroid can be, but just the base size of what the asteroid can be, and that's modified from within the program. Resource. OR units. OR produced. OR cost, and ORP loss. Alright, so that's all those done. How many lines is this bloody class now? Or So it's still, I think it's still smaller than ship is. I think ship is like 24 something. We're up to 2136. Yeah, 2984 for ship. Damn. Yeah, 2136. So, that should do it for that. I don't think we'll need to load anything else or write anything else in terms of the saving or loading, because that's not really something that, none of that information is actually saved or loaded. It's just there for, like the other database stuff is just there to provide information to the game as it needs it. Now, back over to asteroids. You may have noticed over here we did there's some differences here, and also some of these. What I'm doing is I'm writing things and seeing that they need to have external values to be loaded in for modding purposes. I'm putting in these tags, and I'll be doing that for all the other code too as I go through it and look for stuff. Just so I can easily find things that have to be placed outside of the program and brought in through an import. And all I have to do is just look for a comment named external value tag, and that'll load up all the things. For example, find, let's, external value tag. And I just have to search for that, and we say find blah blah blah. I'm going to say entire solution, find all, and we'll get all the different places where I have those tags at, and I'll be able to easily find places where I need to have an external value and be able to deal with it. Just makes it a little bit easier when I start going through for 0.6a, because that whole process is going to be extremely difficult in terms of how much code has to be changed and how easy it will be to miss things otherwise. And this is just a clerical kind of task that'll help me with that. But anyway, so we have a few new things here. First of all, over in Asteroids H, you will see that the mined asteroid is gone. I removed it because that's going to go into the mining class. And I added a create asteroids function that will actually create the asteroid and then add it. So I realized I hadn't put the code in for that. We also added 2 new, actually 6 new values here, variables. RAN34, number of asteroids, asteroid ID, and then some looping ints that you might need, that we will need later, or are going to use now. Over in asteroids now, though, I also changed some things here. So the number of asteroids per belt is going to be randomized by an external value range eventually. Right now I have it set to 8 to 35. That'll be different also depending on the difficulty. And this just tells you how many numbers of the number of asteroids a belt will have. And well, it gets complicated later on though because of this. For the belt size, we take the number of asteroids times a value range here, again going to be external, times 13 divided by 6. And I found that gives a pretty good value. For example, let's say we have a belt that will have 12 asteroids. So the number of asteroids times a random, and let's say this random is going to be a larger one. So times, let's go 3,485.52 times 13. And then we divide that all by 6, and we get a total max size for the asteroid belt of 90,623.52. So that becomes the asteroid belt size. Now what we have to do is we have to determine ways in which we want to fill these this space with. And I think I'm going to do a simple random probability kind of thing based on the difficulty. That too, though, if you think about it, means that we have to have either a modifier or we have to set the value based on the difficulty for the both the percentage chances and also for the value ranges of the random. So what we're going to do is we're going to come down here and we're going to say well, first we're going to create the random, so we'll use rand3. So rand3 equals random 1 to 50. We'll do something small for now. So now what we need to do is we need to calculate out some values, percentage values, correspond them to actual values. So we have 50 here, and we want to find the what 75% of 50 is. So 70, want to go times 0.75. So 50% of 50 is 37.5. So that corresponds to 75%. Now we want to find 15% for 50. So do the same thing. And 7.5. That's 15%. And then 5%, which should be 10. No, 5. Oh no. What would that be? 5% of 50. Well, allows a 5. So 2.5 then. Probably is what it is. Yeah. Okay, so 2.5. That's 5%. So now these values we just calculated are going to be the value ranges for what gets put in the fields for right now. For testing purposes, though, we'll probably do, I'll make a comment here. So, small, 75%. Medium, 15% of random max, I should say. And large, 5% of random max. Alright, so now the problem with having this kind of a setup but also having a number of asteroids set up is that we have to consider both of these constrictors to, or I guess not constrictors, but requirements, I guess. Conditions, I suppose, would be a better word, I guess. These two conditions, which is that we have to have a certain number of asteroids, and that those numbers of asteroids have to conform to whatever this size is. So, what's going to happen then is we're going to have this for loop, which is going to be inside of a while loop. We'll put the while loop in now. And it's going to go through until we get to a point to where we either have the number of asteroids entirely filled, or that we have AB size filled. Now for one, the AB size can still be not reached and have all the asteroids, but with the AB size, what's going to happen is it'll keep going through this until it reaches AB size equals the max. If it's going to go over it, and it'll keep going through until it creates an asteroid that will allow it to be equal to this. But we're only going to use that if the temporary size is greater than what AB size is. Otherwise, we'll just have the number of asteroids, and that'll be that. But you will always have this, whatever this number of asteroids value is equal to, will always be present. So you'll have 35 asteroids, but they will conform to whatever this is, or will be smaller than what this is. So let's go back over to the database here. Did I finish another skill? Apparently I did. Cool. It was either, I think it was this morning that I did these other changes here. I was going through and looking at the, I gotta apply that. So I made some changes somewhere. Got to apply the, so I was going through looking at this stuff, thinking up of, doing some calculations, seeing if the values worked out. And, I noticed that, the base size seemed a little off, and if you see these where these were before, you'll probably have noticed that they're smaller down here. What I decided to do was I decided to say, okay, in order for one of these asteroids to exist, how many resources must there be by default? And I decided to do this in an interesting way. Instead of creating another field just to create a default number of resources that it will contain, I decided to use SG2 and base size together to do that. And so what happens is that I decided, like for example, for Pyrax Minor, I decided there's always going to be 2,500 rubies available in a, or 2,500 units of ore available from that type of asteroid by default. It will never be less than 2,400. So I went in and said, okay, so we have 2,400, and then divided that by 0.18, and that's how you get the 13333 thing that's there. Is that really what it was? Okay, there we go. I must type of the entry. That's how you get the 13888.9. So you get the 9 here, which essentially rounds all these up by 1. So they put 9 here. And we did the same with the other ones. This one for Pyrax Normal was, I think, 1458 divided by 0.22. Yeah. And the last one was I forget. I think it was 876. No, what was it then? So 3622.7 times 0.34. So it was 1231 for the Pyrax Major, and that actually is a bit high. We should lower that more. Let's make sure they 1231 divided by 0.34. 3620. Let's actually make that lower. Let's go 975. 2876. 0.65. 67.65. And this just creates a standard lower value that can be used for that. And one that's actually tied to the actual number of resources present inside of the asteroid. So I thought that was a good logical flow through, that the size of the asteroid would be directly related to the amount of ore you could take from it. So, what we need to do now is deal with this. So we have the random range here. Of course, we don't really even need this anymore because we're going to go with this method. So it's just going to be 1 per. I'm going to put in. Actually, we'll keep this because what'll happen is once we get this done, I'll go and weld some more types of ore here, just so we can make this actually useful. So rend, let's go and put the while loop in. So while B AB is not full. Now again, this is kind of a bad descriptor because the asteroid belt, well, no, I guess you could say it would work because the number of asteroids is a descriptor for the asteroid belt. So if the number of asteroids is full, then the belt is full. It doesn't matter what the size actually is. So I guess that does work. And again, following the bool style naming, bool asteroid belt, the operative word of the question at hand is, so is fully listed there and full, not full. Let's go ahead and add that to asteroid H here. Bool B asteroid belt is not full. Bool. Continue. Or let's do it this way. Is AB full? Is AB not full? And we'll do is AB full. We'll take out the not. Alright, so, I'll put this down here. And what this is here is the size of the asteroid, and we'll get into that later. So, rand 3, 1 to 50, so we're going to be doing this based on floats, since I calculated out a float values with the little calculation round we just did a little while ago. So we're going to say if, that's an int though, it's not a float, so we'll put a rand 5. Because we need to have a random if you want to go by floats here. So if rand 5 is less than or greater than or equal to 1.0, and rand 5 is less than or equal to 37.5. So this will be for a small asteroid. else if rand 5 is greater than or equal to 37.6, and rand 5 is less than or equal to so I guess that would be 45. But let's go the other way with that. This is calculation done. We want to go up with that. So we actually have to do the opposite value. So we need to find 25% of 50. So 50 times 0.25. Damn, that doesn't work. Then plus 7.5. So 75 and 15 equals 90, if I'm not mistaken. Oh, so it should have been 10%, not 5% on the bottom. My mistake. Should be 10, not 5. It's really, we only have 95%. So it should be 10 then. Or 5 rather, not 10, but 5. So we have 37.5 plus 7.5, which is 45. Then else if rand 5 is greater than or equal to 45.1, and that'll be for large. Actually, not large or medium, but the stage 2, stage 1. Essentially, the stage represents a either a compression or a purity type, I guess. For example, using Eve, because this is what I'm modeling it off of. In Eve, you have 3 types of different ore for a specific mineral. For example, Veldespar. You have Veldespar, condensed Veldespar, and then dense Veldespar, and that progression corresponds to not only an increase in weight of the ore and a decrease in the maximum amount of ore possible to get, but also in the amount of ore that you can get per unit, the number of units needed, and also the amount lost. So think of the stage 1 as being the least purified, but more in quantity, while you're going down per stage, you get higher quantity, or higher purity, but less quantity. Essentially, that's how you can think of it as. Alright, so now we need a temp size variable to hold the stuff in here. So temp size. So what we're going to do now is we're going to reset that up here. Well, first let's set B is A, B, full to false. And then we'll reset temp size to 0.0. Alright, so we have our random gone through, then we go down here and see what's happening. So now we need this. And grab that. Put this up here. Alright, so we go in and we get the range here. And so this will still correspond correctly. We'll have to change the values in the database because we'll have all the stages of ores ordered by their stage. So we'll have all the stage 1s together, then all the stage 2s together, then all the stage 3s together, so we can go through them like this, instead of having to try and do a random on like a array or a vector of values corresponding to table IDs that are scattered and whatnot. Okay, so we get the ID that we're going to use, the type of asteroid, and the types of asteroids will also be dependent on some other variables that will be added in later, much later on in development, maybe towards 8 or 9 of the alpha. What we want to do with this now is we want to actually get the data. So we want to go data system a.r data. Then we want to type in, I think it's OR. I'm also going to be changing how this R data works in data system. And instead of sending through the table, you're going to send through a string of whatever you're trying to find, data for the blah blah blah, whatever type of item you're trying to find the data for, and that'll be what the LSys will look at. And then you do the table stuff as you see here, and I'll be doing that for all of these other ones as well. This just allows me so that we can use this kind of a setup where we have the table that has multiple types of data, and we only want specific types of data from that table. You kind of have to do it this way, otherwise you have to send through another parameter that says, okay, we want this table, but we only want these resource fields, and that would just add, I think, too much complexity over what we have here, because then we'd have an else if, then if blah blah blah, and have to do this multiple times. Instead, we just do it like this, and it's a lot easier, I think. Certainly a lot less stressful on the code, on the CPU too. So we do that, then we send through. We won't have to send through any of the other stuff either, except for the ID, because operation. Well, no, we do have to do operation. Operation is still there, so we send through everything else, but the it's not dtable anymore, or table, whatever the value is. I guess it's just table. That will not be table anymore. We'll blah 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 yet again. Trying to talk too fast is the problem. We'll rename that parameter to something else instead of table. Thinking too fast for my mouth to keep up. Same problem with my fingers when I'm typing stuff out that I'm not dictating or just copying from some other source. So we get OR, then operation select from, and then the ID, which will be a ID. And then we just get the data. So a name equals get o name. We need to get the We won't need the, well, no, we will need the description too. A desk equals, so we'll add that over here. I don't think we added that. String a desk. A desk equals won't need to do the type because that's quite obvious what it is. Then we'll need the base size, which we'll use as the temp size. So temp size equals dsa.get OB size. Let's see, what else do we need? The name of the resource, we'll need that too. Oh, resource, yeah, duh. Let's see, what else do we need? Actually, no, that won't go here. What I'm thinking of doing is creating a new thing for item or something. I don't know exactly how it's going to work out yet. What I want to do is I want to take ore and make it into its own class or struct or something, so we can use it differently than item. But I think what we'll just have to do as well is add the field to item for this this resource field, and also the other information as well to item. Actually, no, because the way items are stored, they start by the ID, so I could just go look for the ID. Because you get the item type, and the number of items that you have, and the size. That's right. So it'll work that way then. Okay, good. It'll work the way we have it here. So we actually don't need this. We actually don't even need to grab that data at all, now that I think about it. Because we'll just be able to get it from the database whenever we need to. So let's go to data. Well, we'll leave that there for now because we'll still need it sometimes. So for the moment, we'll leave it there right now. Unless I think of some other way to do that. So desk. So we got the size. We've got, well, the temp size. We've got the name description. We've got the ore name. What else could we possibly need? And the other stuff doesn't apply to this asteroid. Okay, we'll take that out. I guess that's all we need then. It just does. Oh, the ore name. Let's go here. I think I removed a field from here, I removed the ore field, didn't I? Let's go ahead and add that back. Because now that makes sense. I don't know why didn't think of that before, but ore, that's gonna be the it's gonna be Vercare. Yeah, it used to be in between used to be somewhere, I don't know where it was, but I'd actually removed it. So let's move it up to our resources. Put underneath resource there. And I'll go add it to the code as well. So apply. Let's go add our values here. Just as long as it's not null. Although I may put that as null anyway, so we'll do none. So Pyrax, Pyrax, Pyrax. Alright, back over here. Let's see, data placeholder. O name. I'll call it O name too, just because I already have an O name. Or I could go or. Or better yet, what's the one for R? Maybe there isn't one. Or and Haxor. No, word name 2 sounds too corny though too. So we'll call it or. That's marginally less funny and marginally less insane than the other two choices there. And to database we go. Well, data system first. We're going to add in the add that in. Now get our results. Let's copy and paste this. Alright, so we got that added in now. Back over here. Alright, now, we need to determine the size of the asteroids. Their actual size. So we got this down here. It's a formula that we're working on here. So that one is actually for the total asteroid belt size. Or maybe not. That one's for the asteroid size. Okay. Alright, so let's also add a let's put this above here. So, temp size. Let's go ahead and make 2 temp sizes, because we need one that will store the size that we pass from the database, and then one that will store the total size. And we can't be multiplying the full size by whatever that calculation is, because when we do that, then things get insanely huge and things don't work. So a little bit of preventative bug debugging, coding, I guess. Preventing bugs before they happen. It is literally the code version of Minority Report. So we've got the temp size of the asteroid, which is the base size of the asteroid. Then we're multiplying it by a float range. Then that gets added to temp size 2. Well, let's do it this way. That gets set to the asteroid size. And then temp size 2 has a size added to it. Of course, we missed a step here. A size equals that. So we do add that back to temp size 1. Alright, so let's walk through this here. We have, let's say we have an asteroid that is of a base size. Let's say we have a medium asteroid here. Or rather, the stage 2 for Pyrex. The base size is going to be 6750. Alright, now we have that's at the temp size. So we come down here, 6750 times 10 divided by 4 times 1.23. So that means that asteroid would be not correct because we actually didn't do the first part. So again, 6750 times the float random, which we'll say will be 1.07. Now that times 10 divided by 4 times 1.23, and we get 2209. So 2209 point. We'll call that 19. And if we want to find out how much ore that would have in it, we would divide that by 0.22, or multiply it. No, divide it, yeah. So that would have 100,950 units about of that ore. Now, to check this, we're going to take that, let me write that down here. .85. Yeah, because 7, the 3 doesn't allow it to go up, but even if it wasn't there, 7 would go to 2, which would go to 3, which would be still 7, because 3 is not over 5, so 8.5, or 0.85. 0.852, in fact. Because then this goes into the 277 all in a row there. So, to check this now, we want to go 100,950.852 times 0.22, and we get that number. Yeah. So, actually, it should just be 187, not rounded up, because the 4 does not allow it to be rounded up. But it doesn't matter. That's essentially how it would work, without the rounding. But that all conversion thing holds true, checks out, so that's what would happen. So you get temp size, and then we go temp size again. Or no, A size, because now A size is going to be temp size 1 times that, so this second multiplier here is going to be the external value, and that'll be based both off of external value and difficulty. Temp size 2. Oh, missed the semicolon. Now temp size 2 goes to there. So now what we want to do is, when we're going through all this, at the very bottom we want to say if temp size 2 is greater than, or is less than or equal to, greater than A, B size, then you want to do something else. Temp size 2 is greater than or equal, is less than or equal to A, B size. And then down here, then we also put in if what the hell's the vector name? Asteroid. No, A belt. If num of asteroids equals A belt dot size. Then we say B is AB full equals true. Now what we do here is we examine this. If this is greater than that, that means that whatever asteroid just got added was higher than what was needed to get to that size. So what we'll say is essentially we'll essentially remove that asteroid entirely, and then let the code go back through and create another one, and keep doing this until either this becomes this or this becomes true. And we'll do another else check here. Equals A, B size. B is AB full equals true. So we go A belt dot erase A belt dot begin plus A belt dot size minus 1. So this will remove the very last element added to the A belt vector. Alright, so that's the temp size, A size. Bring this back up. I don't think we need anything else for this. And we can just take this now and copy it down. The ranges will have to change, but everything else should be fine. Or rather 37.5, 37.6 through 45.0, and then 45.1 through 50. Because what we're going to do now is we're just going to do it in equal amounts. So we're going to have essentially, well, this one be one higher, but the other ones will be both 33 and 33. This one will be 34, so that we can get a full a full 100%. So 50 times 0.33. So 16.5. So 1 to 16.5. And then we need to add that 33. And 33.1 and greater. Alright, so that'll be the test values we use, so we can have them all in equal measure, except stage 1, which will be represented 1% more than the other two. That's equal to 100% now. So we weren't done quite yet. We actually have to add the asteroids now too. So we have to make the create asteroid function. So void asteroid add asteroids add asteroid. I don't know if we actually need any of that stuff, because all that stuff's going to be saved internally anyway, so we actually don't need to pass anything. I was thinking that we do that by having them created in another function, but we don't actually need that now. Alright, so the O amount is something else we'll have to also create here. So to get the ore amount, we want to take the size of the ore and do our calculation with that. We'll just get that from the data stream. We won't actually bring that over. So we'll say AO amount equals is that a float or yeah, float? So, equals. So to get the amount, we would go the size of the asteroid times the divided by the so we get the size, which will be a size. So I'll have to do this underneath the this section, divided by the DSA dot get O SG2. And that'll get us the O amount, or amount. Okay, and then add asteroid. So what we will do is we'll do this on a constructor. Alright, we'll go ahead and add that to the implementation here. Now this will need to be passed because we're essentially creating a new object, even though it's within the exact same friggin' class. So, a name equals name, which is the asteroid name. A O name equals O name, or name. A size equals size, and AO amount equals O amount. I believe that's all the different things we need. Yeah, we don't need to do the well, no, we do need to do the description as well, don't we? So we'll add that as well, the description. So now, down here, we essentially will push back the, so a belt dot push back asteroids, and we want to use the third constructor here. So name will be a name. That's kind of backwards here. AO name, a desk, a size, and a O amount. And essentially that's all we need to do with it. And that just repeats over and over and over again until the while loop is broken. So, need to call add asteroid. Alright, so let's see what some of the other functions we need are. We got an add asteroid, update, or amount. In actuality, I don't know any time when you would add or back onto the asteroid. I guess if the player didn't mine the entire thing out, over time you'd want it to recollect its value, maybe. It doesn't do that on Eve, but again, we're trying to not copy Eve, but just give an homage to it, and all these other games that we're taking elements and ideas from. So void asteroids updates or O amount. And then we also need to do a few other things here too. We need to get the name, so string get a name, string get a desk, string string get a B name, string get O name, and I believe that's all we need. So we'll add the remove asteroid. Actually, like we well, it'll essentially be the same as we did with the create asteroids function. It'll be that erase code. The I is essentially the slot, the element that you want to remove. So a belt dot erase, a belt dot begin plus I. I'll probably add some messages or something in there somehow to help make it a bit more clear what's going on inside of the game. Now, need to add all this stuff. I want to put the damn parentheses on there. So that's pretty much that class made now. Maybe some debugging and other changes that will happen as I'm testing it, but for the most part that's the basic beginning stage of the class. I just wanted to do this entire, show me doing this entire class just as an example of what exactly it takes to do an entire class and some of the thinking behind what you need to have in a class to make it work. But I think we're going to end the developer's vlog here for right now. And maybe entirely. I might do a little bit more on the audio side, but I'm not really sure about that. But for now, just operate under the assumption this is going to be the final recording that we're going to do for Developers Vlog 9. By the time this gets released, 0.4 should be out, and we'll be working on 0.5, or rather, build 4 will be out. We're working on build 5 of 0.5 when this video gets uploaded and the update is released, progress update, that is. I believe the schedule for it is let's see. Yeah, April 12th is when the when Build 5 will be released, and that's when we'll start to work on 6A. Is on or the day after. So, thanks for watching these videos. Hope you enjoyed them. If you have any comments or questions, leave them in the comments section below. And if you have not yet done so already, we'd appreciate it if you would subscribe to our channel. And until next time, this is GOL, and I will see you later. Sweet, found another block.